Hi folks, welcome back to Math with Captain Rod. The purpose of this video here is to finish your notes or start your notes on section 15.2, and the topic of that section here is how to find the minimum or maximum value of a quadratic. So first let's remember what quadratics look like, or what parabolas look like. You know, they typically have this type of shape, or maybe like this. They either open up or down. Now, if they open up, they don't have a maximum value because this graph keeps going up forever. But they do have a minimum value, and that minimum value is right here. That's the lowest point on the parabola. This animal here, anything that opens down, doesn't have a minimum value, right? Because this thing, you know, these arrows, this thing keeps going down this way forever and this way forever. But it does have a maximum value, and that value is right there. In either case, the min or max, you'll notice, is at the vertex. So, you know, one kind of standard form for a parabola looks like this: y equals a times x minus h squared plus k, where the vertex is at the point hk. So, the h tells you where the min or max is, and the k tells you what the value is, long story short, because the min or max is at the vertex. So I'm going to go through some examples here. We're going to take a look at the first one on a handout here, where it says f of x is equal to x squared plus 6x plus 8. All right, wanting to find the minimum or maximum value. Now, I should probably take a moment to note of which one you're looking for. You'll notice that the value in front of the x squared is positive, and that means this parabola opens up, so it looks like this one, and we're going to be finding a minimum value. In order to find that value, we need to take this and make it look like this. And the process for doing that is completing the square. Now you notice I moved the 8 over. When you complete the square, you are always focusing on this stuff and pretty well just ignoring the constants, at least temporarily. And again, the idea behind completing the square, you look right here. It's all about this. You take that guy, cut it in half, that would be 3, square it, that would be 9, so I'm going to add a 9. Now you can either add 9 to both sides, or more typically with problems set up like this, I've got a plus 9 here, I'll just move over here and subtract 9. So now by the time you do this, you haven't changed the value of anything. We're all, you know, still equal everywhere. This guy now, by design, is equal to x plus 3, the quantity squared. And then over here we're going to have 8 minus 9, which is minus 1. So here is our function. I'm going to go ahead and write it y equals, right? And again, y and f of x are the same thing. The vertex of this animal is at the point -3, -1. Now this is not v times, I'm just labeling this point here, putting v here. This is the coordinates of the vertex. And again, it's -3 here because when you compare these two, this is x minus h and this is x plus 3, so the h must be -3. And then there's your k. So the minimum value, I'll put y min here, of this function is this, -3. Now, the directions in the notes don't actually to say what is the x value, but that would be this guy. That's where that value occurs. Let's take a look at the next one down. Let's get rid of this. All right, next function is f of x equals minus x squared minus x plus 6. Now I'm going to take note here that we have a minus sign in front of the x squared. That means this thing opens down, and what we're going to be finding is a maximum value. Okay, completing the square is not fun when we have a minus sign in front of the x squared term, so I'm going to start by factoring that out of these two terms. I'm going to leave myself a little space because I know I'm going to be adding something, trying to put this, or turn that into a perfect square. We'll just put the 6 over here. So again, completing the square, you're focusing on this stuff. And we want the term in front of that x positive, so we'll just factor a minus sign out of both of these. Okay, to complete the square, we look here now. Although it's not written, there's really a 1 sitting here. So the term in front of the x is a 1. We're going to take half that, which would be, you know, 1/2, and square it. That would be 1/4. So I'm going to go ahead and put a plus 1/4 here. Now, you can't just add something to an equation because you've changed the value. You have to maintain equality. We either, we have to do something else here to kind of cancel that effect out. Also take note that I didn't really add 1/4 because of this minus sign. What I really added was minus 1/4. So what I'm going to do is move over here and go plus 1/4 so that now I have not changed the value of this equation in any way. Okay, the minus sign stays. This now, by design, is equal to x plus 1/2 the quantity squared. And looking right here, let's see, now 6/4 and 1/4, I'll just do this off to the side. That's 24/4 plus 1/4, 25/4. Okay, so got a lot of information about our parabola now. One, it opens down because of this. The coordinates of the vertex is, let's see, minus 1/2, 25/4. So the maximum value is this guy right here. I'll put F max is 25/4, highest value on the parabola. All right, call that one good. Move on to the next example. All right, so next example I see, and I'm going left down the page, f of x equals minus x squared minus 2x plus 1. All right. So again, taking note here, I see that this is a minus sign in front of it. I know that this thing opens down. Therefore, we're looking for a maximum. And again, we want to make this look like this. Step 1 here, I've got a minus sign. I'm going to just get that factored out of these two terms. Leave myself a little space for the, what do I have to add here to make that a perfect square? This plus 1, we'll just put it over to the right, kind of on hold. Completing the square again is about this stuff, and the first thing you do is you look right here. You take that value in front of the x, which is a 2. Cut it in half. That would be 1. Square it. That would be 1. And I'll pop that right there. This now, by design, is x plus 1, the quantity squared. Now, we have to maintain equality. Right? You can't just add 1 without taking that into account somewhere else. And I didn't really add 1, because remember, there's this minus sign sitting in front of this. This minus sign applies to this. What I really added was negative 1. So what we'll do is come out here to maintain equality and add 1. I know that looks funny, plus 1 and plus 1, but this really isn't plus 1 because of this minus sign. All right, so our function now is equal to, looking at this guy, that's going to equal x plus 1, the quantity squared. And over on the right, 1 plus 1 is 2. All right, so again, in this form, there's lots of information to kind of glean out of this. 1, looking at this guy, this thing opens down, something like this. So we're looking for a relative maximum. The coordinates of the vertex are minus 1, 2. I'm getting that by looking here and comparing it to this formula here. And again, x minus h, and this is x plus 1. So the h has to be minus 1. Okay, so our maximum function value is this, 2. And it occurs, it doesn't ask for this in the notes, but it occurs at x equals minus 1. All right, so I think I will stop that video there and start another one for the word problems. Actually, no, I am going to do one more example. I'm sorry, I looked over here and I see one that's quite a bit different than the others. I'm going to do that upper right one in your notes as well. Then I'll move on to a new video. Okay, one more. So we've got one, f of x equals minus 2x squared plus 8x plus 5. All right, taking note of this, a minus sign I see, so this thing is going to open down. So we're going to be looking for a maximum, and we don't, when you complete the square, we want a 1 in front of this. So let's start by factoring a negative 2, from both of these terms. And leave a little space for adding stuff. And again, minus 2 times minus 4x, there's your plus 8x. And this plus 5, we'll just put it off to the side. All right, then we start working in here, and again, we got to complete the square on this. We look here, and we see a -2. It doesn't really matter if you include the minus sign when you complete the square, because when you square it's positive. But if I take -2, cut it in half, I'm sorry, if I take -4, cut it in half, you get -2, square it, that's 4, so let's go plus 4. Now, being a little cautious here, this thing, it looks like I added a 4, but I didn't. There's a -2 in front of this, so by the time we do this product, that's going to be -8. So out here, let's put a +8 to counterbalance that, so to speak. This now, by design, is equal to x minus 2, the quantity squared, plus these guys add to, what, 13? And I guess I don't need that parenthesis, that square bracket anymore. I'll get rid of that. We don't need that one anymore. All right. So vertex is at the point 2, 13. Maximum value, F max, is 13. And it's a maximum value because you'll notice this guy opens down, so it's a max instead of a min. So there, now I'll end that video. That should be enough to get you through the rest of the notes here on 16, or at least this part of the notes on 16 too. Have a great day.